Okay, here's the second half of your test being reviewed, okay? Here we are, we're cutting out the box, cutting out the corners of a rectangular sheet to fold up to a box, okay? All right, the cuts are X by X. So the dimension previously was 20 inches. Okay, when we cut out X by X, our new dimension here is 20 minus 2X. Okay, uh, the width dimensions were 14. When we cut out the X by X, over here it's 14 minus 2X. Okay, so the volume is length times width times height. Okay, which is the volume as a function of X then is the height, which is X, the length, which is 20 minus 2X, and the height, which is 14 minus 2X. All right. And so the length we designated as 20 minus 2X, the width as 14 minus 2X. Now, what is the range of values for X? We can't cut off more than half the shortest side. So X is going to run between 0 and 7. All right. The rest is for your calculator to decide. Okay. Key to function in. All right. I had one in there from the other version. So it's X times, what was it? 20 minus 2X. 20 minus 2X. 240. 20 minus 2X, and then 14 minus 2X. There was no need to expand that out. There's my function, right? Okay, let's turn this Y6 off. There's my function in Y5. I'm interested in what's going on between 0 and 7. So my table is going to be set so that I can input, ask, I can, well, I don't have to ask. I can just go from 0 to 7. 0 in increments of 1. Okay, that'll work. Let's take a look at the table. We say that this seems to be topping out there, right there at around 3, at about 336. So I'll let my Y values run up to about 400 so I can see the top of the curve. So my window is going to be set to go from 0 to 7 on X, and what do we say, up to 400, okay, on Y. Okay, that should give me a good picture. Take a look at it. All right, here's my curve. What I'm after is the high point on the curve. Negative b over 2a will not do. This is not quadratic. This is cubic. Will not do. You have to go to F5. Okay, the analytical solution to finding that has to be deferred to calculus next year. Okay, F5, left bound, lower bound, that right bound, upper bound over here. Okay, there we go. We're locked in. 2.7 is the size of the cut. 2.7 with 339 as the volume. 2.7. Okay, what we had the function. We'll just write that function down there. Write that function. This function. Put it down there. Okay. X is equal to 2.7. The length and width was what, 20 minus 2 times 2.7, whatever that is, and 14 minus 2 times 2.7. The max volume again was 339. 339. Volume is 339 inches cubed. Okay, done. All right. Here's the triangle shown. All right. Express the area of the triangle as a function of X. Here's X, here's Y. Okay? All right, it's on the curve, it's on the circle. X squared plus Y squared equals 25. So as a function, that's Y equals square root of 25 minus X squared, right? Okay? The area of a triangle is 1/2 height times base. Area is 1/2 of X times Y then in this case, but Y needs to be expressed in terms of X, so we found area as a function of X is 1/2 x times root 25 minus x squared. Okay? That is nothing we can do with that analytically until calculus to optimize that. So we have to go to our calculator. What is the range of values for x? X is this length, which is at most going to be 5. Okay, so we're going to be between 0 and 5. All right, so x is locked in between 0 and 5. All right, let's look at that function on the calculator. Okay, so we have, I'm going to turn off this one, key that in, and that was 0.5 x times the square root of 25 minus x to the second power. Okay, so there's our function. We want to look at between 0 and 5. Our table was set up before 0 and 5. This doesn't peak out too high. We can see it's peaking out somewhere a little south of 5. So our table will be set up here 0 to 5. And you know, we don't need to go much above you know what, let's see, let's take it up to 6 or so. Okay, all right, take a look at the graph, bring it back to calculator. Okay, look at the graph. The graph will show a peak point there. We're just off the peak. We have to revise that a little bit. Our window, we're just out of that. Let's take it up to 8. Okay, all right, take it up to 8. There we go. All right, find our peak. F5, max, to the left, enter, over to the right of the max point there. Enter that. Max is out. X equals 353. The Y value is the area. X equals 353. X equals 353. X equals 3.53. Okay? What are the coordinates of C? Well, C is 353 and and then 353 evaluated back in there, which I believe is going to be another 353. Okay, so that's 3.53 comma 3.53. We're done. Okay, we're done. That's it. That's the end of that test. There's your optimization, non-quadratic optimization with the calculator, finding the high points, and quadratic and quasi-quadratic optimizations using negative b over 2a. That's all we had to do with these. Okay, that's all we had to do. All right.